Hello and welcome to this video. In this video, we will learn about recursion in Python. Recursion is a generic concept which is applicable to other programming languages also. Here we will look at recursion in Python. It is no different than recursion in any other language. When a function call itself, that is called recursion, or when a function call some other function and let's say there are two functions f and g, f calls g and g calls f, then that is also recursion. There are various types of recursion. So here we will deal with simple recursion first, and as we will deal with more complicated problems, we will see other types of recursion as well. So to start with, I have a function mysum which accepts a list, and if it is not empty, uh, then it returns 0. Else, uh, what it does is it takes the first element and then slices off rest of the element and calls mysum again on the list. So first it will take 1 and then rest of the list 2, 3, 4, 5 and call mysum again. And the next call it will become 2 and the argument to mysum will become 3, 4, 5. And then at the end it will wrap around, and that's how the sum will be calculated of this list. So it should print us 15. Let's see this. Oops. I think I made a mistake here. Yeah. So it prints 15. Let's look at very famous Fibonacci series thing. So to start with, I have a function called fib, and what it does is it takes three arguments. Two of those are the values from which next element will be calculated, and it also takes a third argument, that how many Fibonacci numbers it has to calculate, which is denoted by n. So I supply first two Fibonacci numbers 1 comma 1, and n is 20. So now when n is 20, it is not yet 0. What it will do is it will copy b to a, so a remains 1, and then copy a plus b to b, that is 2, and then it prints b, which is the next Fibonacci number, so it will print 2. Then it will supply 1 comma 2 comma 19 to next. Then in this case, a will become 2, b will become 3, and 3 will be printed. And it will continue till our n values is positive. When it becomes negative, it doesn't do anything, and it will wrap up of stack unwinding will happen. Let's see the Fibonacci numbers printed. Oops, there is some mistake here. Line number 34. Okay, here. I have to get that. So these are the Fibonacci numbers printed. Similarly, we can do factorial calculation also. And to do factorial calculation, you don't need to do much. What I have done is I have function fact. If n is greater than 0, then it returns n into fact n minus 1, else it returns 1. And I have given 20 to be computed a factorial of. So while n is greater than 0, it will give 20 multiplied by fact 19. Fact 19 will become fact 18. In the end, n will become 0, it will return 1, and stack unwinding will happen. And so the factorial of this will be computed. That is the factorial of 20. So that is very simple concept of recursion. Note that recursive functions can uh, cause slowdown because it always creates a stack frame. However, there is technique of uh, tail recursion which you can use so that your stack doesn't get overflow. And moreover, every recursive function can be substituted by a separate iterative version with the help of a stack data structure. So the beauty of recursion is that it makes complicated code very compact and easy to understand once you get the grasp of recursion. So I'll stop here. Later on, when we see more of recursion in complicated problems, then we will see recursion in action back again. Thanks a lot for watching the video. If you have enjoyed this video and found it useful, then please like and subscribe the channel. Also, let me know in comments if you need videos on any other specific topic, and I'll try to make videos on that. Thanks a lot for watching the video. Happy programming.